Our next presentation is on soil health assessment, why and what the soil health reports mean. Dr. Zavala is the Soil Health Lab Manager and Soil Health and Crop Management Specialist at Chinook Applied Research Association, or CARA. Dr. Yamily led the development of CARA's Soil Health Lab, which opened in 2018, and under her management, the Soil Health Lab focuses on assessment of physical and biological soil health indicators and allows producers the opportunity for hands-on evaluation of their soils. She's been part of the CARA staff for 11 years and oversees applied research on management alternatives for soil health in addition to processing soils and managing the CARA lab. Please join me in welcoming Dr. Zavala.
Thank you. Good afternoon, everyone. I don't hear my good afternoon back. Okay, so I'm the kind of person that move around, so that's what I'm going to be doing, so bear with me, and then I'm going to be watching who is going to be falling asleep here, because I have a lot of things to share with you. Okay, so you can see me in the background there, sitting, looking at the soil health sampling benchmark and all of the different, parts of sampling for getting information for the soil assessment, specific for looking at the biology and the physical constraints that we have in the soil, and integrating that with the chemistry, which is just nutrients in the soil. So CARA is the place that gives me the opportunity to keep doing what I was doing back home many, many, many years ago. And one of the things that I needed was how to measure the constraints in the soil. Guess what? 11 years later working with CARA, we have a lab for soil health. And that lab is not just for CARA, it's for every producer that is interested in doing everything out of the box. How many of you do things out of the box? Oh, so we're in the same page here. Pretty good. Okay, so you can see there's a new refurbished building, and the idea is that having the soil health will allow us to look at the soil in a different way. How is that different way than the way that we see the soil? Because usually we look at the soil just for the chemistry. When I mention chemistry, it's just minerals in the soil. Because what we only think that we care is how much we need on NPK. Am I wrong or right? You need to talk to me back. Okay, so in this case, we're looking at the soil in a different way because we are trying to connect what is missing, what's happened with the biology and what is happening with the physical properties of the soil. So that is the main goal of the CARA Soil Health Lab. And then you can see right there, I don't know if it's clear, but you can see there is some, kind of hair going like that with a lot of little dots. That's life that we have in the soil. And that is interaction that happened there for the fungi and some of the bacteria in the soil, which is very important for us to know about what is really happening in the soil. So in order for us to know what's happening in the soil, we need to assess this in a different way. In order for us to assess that in a different way, we need to sample it in a different way. I'm just repeating myself, but that is simple as that. And here are some of the tools that we have been put together in order to do that. So you can see here we have different pills with different depths there, 0 to 3, 3 to 6, 0 to 6. And also we have GPS, and then we have timer, we have water, we have different diameter ring, because each one of those tools that you see there have a different functionality when we're doing sampling in the soil. I'm supposed to be walking here with a penetrometer, and then I forgot. But do you know what a penetrometer is? It's one of the tools very important for you to know what the conditions in the soil when you have some compaction. So we use the penetrometer as a way for us to see where do you have that constraint if you have some compaction in your soil. And then I'm a copycat. You will see it after through my talk. I just see what others are doing and try to adjust that to us. In this case, this penetrometer that you see here is a penetrometer that was started using at Cornell University, where I got my degree. When they started in the movement of soil health, they use a penetrometer in order for them to see what's the compaction that they have in the soil, because compaction is one of the important physical constraints that we have in most of our soil in North America, including the States, including us here. So when we use a penetrometer, the way that we use that, or we have been recommended to do here, is different like I started in Cornell when they started the soil health movement. Because here we have the issues, or we want to know how that can go, the penetrometer goes with 300 PSI. Why 300 PSI? Because the 300 PSI allow us to see how far the root can go at 300 PSI. 300 PSI, nothing goes beyond that point. And then PSI is pound square inch. That's what it is. So after 301 PSI, no root is going to go deep into that. So that kind of penetrometer allow us to see that. So we care about how deep you go. And then I'm saying this because it's very important that we understand that. So when we take the penetrometer and then we go in the field and take different measurements, and then we push this, and then we realize that 300 PSI is about 0 to 6 inches, guess what happened there? Biology is get jeopardized. Plants get jeopardized because the rooting system cannot go deeper than 300 PSI. And that's when our trouble started, because the root is not able to grow in the way that it's supposed to do. Another of the tools that we use is just this fancy slips, which are 0 to 3 and 0 to 6 inches. And the idea is the 2 inches diameter that will allow us collect samples in the soil that will be, big enough for us not to destroy our fragile aggregation stability of the soil. That is why we use the 2 inches diameter. But because when you use the little tiny 1 inch that the traditional we have been using, that doesn't give us the real information for measuring the physical constraint. Is everyone following me? Perfect. So we ask for measurement of the water infiltration. So right here we have a way how to do it. There is protocol to follow that, but it's important that we measure water infiltration. Why is that important? Because we want to know where our water goes. We want to know, if it's going to be enough moisture, if we're not going to be losing water, the little water that we get. Okay? And then here is just a little example of some little work that we did. You can see over there that we have what is this? To the right, you have some water standing in that infiltration ring, and this has been 24 hours and the water is still standing there. And then the one that you next to see at your left, sorry, that water went down in 45 minutes. You know what was the difference between those two soils that are right there? It was that the soil to your left far has 2 years just with a cocktail mix only there was 30 kilograms per acre planted during 2 years. So that makes a big difference, the management that you do in your soil. Another thing that is very important is bulk density. The bulk density is important for us to measure. So those are measurements that you do in the field when you are collecting your sample as a part of the benchmark or as a part of the soil health evaluation. Why? Because you are interested in knowing how is the change in your soil based on the management that you are doing and how that change is going to be affecting your carbon, you need to know that. So that's why it's very important that we find a way to measure the bulk density in the soil. You hear a lot about, carbon sequestration, right? Well, this is basic in order for you to know that. So here is, okay, before I continue, I'm going to say this. It's important that you measure your soils in a way that allows you to get information of what's the different status of the soil properties. In that case, it's what's the physical, the chemical, and the biology. It's important. It doesn't matter what kind of lab you choose. It doesn't matter if you want us to do, the analysis for you, but stick with that lab and don't start jumping from one to another because you're going to be super confused with all the information that you're going to get that is not going to be pretty much the same. So with that in mind, so this is what we have been looking at. So we need to look at the biology because the biology gives us some information of what's really happening in the soil. And there is two ways that we measure that in our lab is through a microscope, which allow us to see bacteria, fungi, protozoas, and nematodes, all of the functional groups of that. And an indirect way to do that is just measuring how the soil microbiology is, breathing. In other words, just like, CO2 producing into the atmosphere, and then they were able to measure that. And through carbon to nitrogen ratio, to measurement as active carbon, what kind of that carbon is that source of food for the biology, and also as a, organic matter. The higher the organic matter, supposedly you have a better idea of what your activity of the microbes in the soil are. So physical evaluation, what do we do? Well, we do evaluation of soil wet aggregation stability in the soil, which is just simulating rain and on the top of some soil that have been, prepared for that conditions and see how much of that soil stays stable in the process of measurement. And the other thing that is very important is the in-field measurement that you do, like I mentioned before, water infiltration, compaction, and also the bulk density. Texture, we do texture because texture, all of the other soil health indicators are connected, and then knowing that allows us to see how they work. This is just the same, looking in a different way. So why we had wet aggregate stability and compaction in yellow? Simple. They are very, very important for us to know what's really happening. Compaction, because the compaction will allow us to see how we're going to be sampling, at what depth we're going to be sampling. Because if we have a compaction 0 to 6 inches, that is where most of the biology is going to be having their constraints to live. So that's why it's important that we know that. And then if we sample it, like I mentioned before, and do the evaluation for the compaction, and we know that it's 0 to 6 inches, so we need to think about how are we sampling? We're sampling to know the biology. How do we do that? We split the soil 0 to 3 and 3 to 6. It is a little kind of expensive, but guess what? The Cara Soil Health Lab is your lab. If you are doing the things right, in all the thousands of samples that I processed so far, I only got one producer at this point, a nice lady that is sitting over there, that sent the sample 0 to 3, 3 to 6. I was amazed. I said, wow, this is pretty cool. Why? Because that allowed me to see what's happening at 0 to 3, 3 to 6, and see how the biology is behaving there. Why is that important? Because if you're going to be monitoring your soil, you're monitoring your soil for what? For biology. And the only way that you can know what's happening is that you tested in where the biology has the constraint. So that's the most important component into that. So if you are interested in knowing more about how to assess the soil, in a way that allows you to see all of that, we have a web page where most of the information is, or where how you can take the soil sample. And then I advise to follow the protocols, because following the protocol allows you to take the samples in the right way. And important that you do a benchmark. Why doing a benchmark is because that will give you the whole picture. It's like when you go to annual checkup with your doctor. The doctor checks your nose, checks your eyes, they check whatever, or everything in you, and then they tell you what the your problems you can have, and that's where the management, I don't say management in human, how you say in human? Well, you get you get recommendation of what to do to change your lifestyle so you can get better in one or another way. So, is any question at this point? No? Thank you. Okay, now I'm going straight forward to what I came here to talk about. I'm going to give some examples of the report. This is how the report looks like. And then, this is a copycat of what Cornell was doing, but I adjust that to our conditions here. And this is how, the main part of the report looks like. I'm just going to go through to explain what is there. So the first page shows you what are the constraints, and the second page gives you some suggestion of what you could be doing based on that problem or that constraints that you have there. All the soil, so you have one column right here that is here is this indicators that we measured that I showed you. Here is my result, and here is something that is called a score. You can see the one that has color. That is the score of that result. I will explain in a minute what that is. But when I see a report like this, honestly, I don't care about the numbers. I just look at the color. And then looking at the color is telling me a lot, because it's red. What does red mean? If you cut yourself, what you get? Red blood. So I don't want to say all the things about red things that are bad, but here we use the red to show that something needs to call the attention, which is the warning. And when we have some issues in the physical constraint, in that case, compaction issue, keep in mind one thing. No matter how you do in the soil to manage your chemistry or any other situation in your soil, you are wasting your time. Sorry to say that. Because there is an issue when you have compaction in the soil. Your biology doesn't live well, and the nutrients doesn't perform well, and your water movement doesn't perform well, and then guess what? The roots cannot grow in the way that it's supposed to, and then you are stuck. So that's one of the things. Okay, so we have the pleasure to have the Canadian organic growers to link with us for us to do some of the soil sample for the producer. This is one example that I want to share with you guys. I got permission to do this. And so let's look at what do we see here. We don't see too many red there, right? So this soil is an unmanaged soil. Okay, you have that there's not too many constraints in the physical, only a little bit right here with the compaction, and the compaction is about 9 centimeters deep. And then, so give that information out. Look at this one, more bluish. So the blue is a good sign in this case. And this is named the best. So the producer that sent that has unmanaged, best, and you can see right here that is, what constraint can I see here? Well, I have some chemical constraint here. A little bit I have of the compaction there. Okay, now let's look at the next one. Oh, this one is worse. Do we see more different here? Guess what we see in there? more red color, right? Did you guys follow me? So we're seeing here a soil that has some kind of constraints there. And then they have another soil as a part of this, which has some, again, it has a few constraints, in this case, compaction issue. Now, because we have a lot of the information, this is what's happening here. This is new. This is a new table that I put it into for the organic growers, would allow us to see where is the, carbon, because right now everyone's talking about carbon sequestration, and then we need to kind of, trying to take advantage of the information that we have to generate all of this information. So if you look at this, you will say, oh, the organic carbon then is 42, 42 for the best, and for the worst is 21, 26, and for the R, which is a name R, that's the field, is 24. But when I was putting this together, I just noticed this one thing. Did you notice something wrong with this table that I put here? If any one of you tell me what's wrong with this table, I will grant you a soil health benchmark for free. Did I hear anyone say anything? Nope? Okay. 1, 2, time off. Guess what happened last night, in the middle of the night? I was putting all of this together, and I realized that my total carbon is 0.5% when my total organic carbon was 7.25%. Is that possible? No, it's wrong. And then I sent 21 reports to organic, Canadian organic growers with a wrong table. Am I in trouble? Big trouble for me. And then I was so disturbed last night, but it was good. You know why? Because I have the opportunity to tell you that when you get a soil report, question it. Look at everything. And if you see something that is not right, call and ask questions. Don't trust anyone that brings with a piece of paper with information that you don't have any clue what it is. Well, ask questions. You need to ask to know what each one of those numbers mean. What is TOC? What is TN? What is all of that? Because if you don't do that, why do you do a soil report if you don't understand that? So the idea is that you understand and analyze that in a way that allows you to understand what's happening in your soil. Results like this sucks. Sorry. I'm glad I caught it. Anyway, this is what's supposed to be. Okay, I'm going to go very quickly. Total nitrogen is all of the nitrogen that is in the soil doing for a method that is combustion, dry combustion. Total carbon has to be always higher or equal to TOC, that is total organic carbon. Why? Because you cannot have organic carbon greater than the total of the total. Does that make sense? So look at those numbers, and that's why that's important. And carbon-nitrogen ratio is just dividing, carbon with nitrogen, and the bulk density is important, and, the organic carbon total. It's just a calculation there, how much of the carbon you have per hectare, and that's what's important to you to know, okay? So for you to have that information allow you to see if the management that you are doing is going to be changing those levels there. So the interesting part here, look at that. What sample is this? 3286. 3286 is the best for the producer. He even not doing any analysis, he named this my best. You see how good it is? So those analyses are good because they give you numbers for what you see in your field. And right here, this is the analysis that we do for soil food web. Now, look at this. I don't know if you will be able to look at that, but right here, this measure as, fungi, bacteria, but I want you to see if you can concentrate. Let's here. This component here is an indication of the nematode, that people talk about nematodes, and nematodes are bad, and all the time you talk about they're bad. No. There is probably 95% of the nematodes in the soil that are good guys. Those are the guys that drive the whole process in the soil. You know what? Because you have nematodes that eat bacteria. And how you call them? Bacteria feeder nematode. And you have nematodes that they, eat the fungi. How do you call them? Fungal feeder nematode. And then you have nematodes in the soil, they attack the roots. How do you call them? Roots feeding nematode. This is so complicated. Anyway, so that is what's important, that we know the functional group of each one of them, allowing us to see them in the case. But I have for you to see, so these are the worst. Look at the nematode there, 4 point something, and the other is 0. Okay, see, the best one has less than 1 nematode, which is very low, but the worst part has 4.4 nematodes at the 0 to 3 inches, giving us an indication that you have too many nematodes there that are attacking the root. If you have something that is just going the root there and damage the roots, and the plant is not able to take nutrients because the roots have been damaged, what are you getting? No good yield, right? So that's what I see in this report. Okay, another thing is, I'm going to move with the next one. This is another case. Too much red, right? What is that telling me? There is a lot of constraints in the soil, and then we need to be paying attention to that. So when I look at something like this, where I start looking at what are the constraints that I have here, and then I focus in the physical constraint to try to see what I can do in order to change that. So this is pretty much the same report. And then look at this. It's hard to see, but pretty much most of the soil, because they have all of the constraints, this soil has not been able to accumulate too much carbon. You see? So the reports give you a lot of information as what's happening in there. Here is some of the chemical evaluation of that soil that tell me that it's not only everything that is red there, they also has constraint with too much high sodium, which is also causing issues. They have too much magnesium, they have too much calcium, too much potassium, and too much sulfur. It's very, very, very complex. Okay? So when we have, that's the reason we need to understand all of this in order for us to see what we can do. Here, this is just part of how to show the biological component. And another thing that has caught my attention here is this part right here is where we have protozoals measurement there. And the protozoals in this soil is very low in comparison what it is supposed to be. Now, how can we improve some of the biology here? I don't know. You have a really good source around in Saskatchewan, which is the alfalfa pellet. I don't get any commission with them because I don't work with them, and then I don't do things for commission. So what I see here is that the analysis that some sample from some remediation group sent it to me showed this. So right here they have a control. They have some spill, and they use the pellets, and there is no pellets and the control. And then if you look at the one that has the application of the pellets, you can see there that they has, the biology is higher there. They has high numbers of protozoals, which is a good indication. And then when you start looking more into the fungi, look what's happening here. You see, look at the different types of fungi that they have there. They have clear, brown, tan. What does that mean? That the biology there has been improved for the application of those pellets in that sense. And look at right here, the levels of the ratio that everyone is talking about, the fungal bacteria ratio. This is the highest that I've seen in more than my 5,000 samples that have been processed. And this is an indication of, some effect that they have, which is very important. Another thing that I wanted to show here is, let me see. Yep, right here. Look at the nematodes. The nematodes where the pellets were applied, look how big they were, the bacteria feeder, which is good that we have a lot of the bacteria feeder, because when those nematodes eat bacteria and they poop it out, what do they poop? Nutrients. And that's when the plants get all of those nutrients readily available. Another experience, just looking at the biology of the soil, this is a producer that also named best, worst, and average. Look at right here, the flagellates, protozoas count, 44 in the best, 27 in the worst, 32 in the average. And look at the diversity they have in the biology of fungi. So I'm showing these different examples so you can see how important it is in a single microscope that you can measure what is changing in your soil based on the management that you are doing. Here is the same one with the different colors. And then you can see, look, 44, the different colors, the diameter, and you can see the diversity of flagellates. The flagellates here is 15,000, 31,000 for, the best one, and 1,000 and 3,000 for the worst and the average. Everyone's follow me in this sense? And the next one that I'm going to show you, it blew my mind. This is a producer in Alberta that has been using biological amendment that he does it by himself. Have you heard about this Johnson & Sue bioreactor? I've been processing that Johnson & Sue bioreactor, probably samples that came from Ontario to BC, the whole province. And then I've been processing a lot of compounds, organic compost and things like that. The Johnson & Sue bioreactor is the one that has the most biological diversity, fungi, protozoals. And even though you do that with your own material from your own farm, you are able to wake up the biology that you have right there, doing that in your place. I don't get commission for that. I brought them this year, in the summer to do a tour because I was unconvinced with something. I want you guys to get it because that will help you to accelerate the process for improving your soil. So this is Chori Fenksy. I probably some of you know him. And here are evaluations that I did in 2021, 2022, 2023. I wanted to go this year, but I couldn't. I'm going to go in the fall to see how the things are. I'm going to make a close-up, and then you can see the numbers. This is what we measured in 2021. Look, he called home 90, probably that's the good, and home 90 bad. Look at the numbers, okay? So the numbers here give me an indication that right there, his protozoals were high in that sense. And then, but look at the summer and the fall the samples was taken. These are not from the same area. I want to make this clear. This is from his farm, from different places. But if everything is treated the same way, there's a big chance that pretty much everything is the same, similar. Now, look at this. Summer of 2022, Just look at the flagellates by themselves. I see 5 million of flagellates there. Look at here, 3 million. And the lowest one is highest than the worst that they have in previous years. When I was measuring chori sample, you won't believe this. I spent hours and hours looking at his biology, fascinated for what it was there. That's what I want you guys to do and see. Because when you look at the soil biology, change it in your soil in that way, that is going to make you to switch and change and start doing out of the box. Well, some of you do things out of the box, right? It is amazing. I've been seeing creatures never seen before. I built up a scale where I had a small, medium, tiny, large, blah, blah. I had to modify my scale and write it like a giant. Now I found giant flagellates, giant amoebas, and different ones. One of my producers there that sent the sample, when I find something, I send it to her. We had the pleasure of naming the creatures in our farm, in our soil. And then when I sent one of the first time that I saw different, it was an amoeba, it was gorgeous. I sent it to her, and then she said, Yamily, what is this? I said, I don't know the name. And she said, can I name it? It's yours. So she had the pleasure of naming her amoeba from her own farm. Here is also, just to show you, look, it's about 3, and then the changes, of the different, biodiversity. That's what I'm showing there with those tables, biodiversity. That's what you need to look. If you have 3 colors and you have only one different diameter of that, that's no biodiversity. But if you have 3 colors and each one of them have 5 different diameters, that is diversity. And that is the only thing that I can see when I'm measuring the sample. Imagine what is there that is not even looking at. Okay. So to answer the question. So why do we benchmark? Simple. To find what are the constraints that you have in your soil. That's one thing. Now, what is a soil indicator? Well, a soil indicator is that soil property that allow us to measure it and see if that changes based on any management that we do there. That's what it is. So we're measuring soil indicators because that gives you information, and that's what you need. And that's me. Anyway, so what do we do with that? First, we look at the constraint. Second, what do? We find a strategy and start checking on it. You see? And then what do we do next? We start monitoring changes. You can start monitoring changes through the lab again, or through yourself when I start putting all of these little tiny, in-house protocols that you can monitor that are already working on it. And what else continue you doing? Oh, it didn't work, whatever management I did there. What should I do? Okay, keep monitoring, because anyone that can tell you that this is the solution for that, don't believe that. And you can tell them that I say that. You have to monitor what you have so you can understand what really is happening there. That's what's important and beauty about all of this. So as I said, the soil health benchmark will report indicators, and that will be your baseline for physical, biological, and chemical constraints that you can have there. And you will start monitoring, any management alternative for soil health. I've been calling that MASH, Management Alternative for Soil Health. It's your management. It's unique to your conditions, and you need to learn more about that. Okay, so how do I start that? Well, I will start looking at that constraint that will unlock other constraints in the soil to heal that condition of the soil. I give an example at the beginning. Compaction. Compaction or poor weight aggregation or any physical constraint is gonna jeopardize the biology. It's gonna jeopardize you nutrients. So you have to look at that one. If you come here and try to fix your chemical, what is gonna happen? You're only giving an aspirin. You're not going to the root of the problem. Okay, so I have a question of what this soil score function is or where that comes from. I think you guys need to know this. We at Alberta, through all the associations that we had there, we got united and we start doing soils through the province, and this woman here has to analyze pretty much everything. So that gave me a lot of information, and that gave me the base foundation for what we have for all of us here in Western Canada. Because what we're doing was everyone was following the same protocol. Samples were collected in different parts of the province. We got all of this in a way that allowed us to be all in the same page. And then the data that we generate for that, this is the last year, and then cross your fingers that next year I will be able to put all of that together so we can have the whole information for 5 years that allow us to see where we stand with our data, with our own data 100%. Because what I'm using right now, I stole it. No, I didn't steal it. My body, when you go to university, you got body there, right? So my body from Cornell allowed me and teach me how to put the framework together. And the reason I got that is because I can adapt that to any place that I'm going to be in the world. It was adapted in Kenya, I don't know, in Tanzania. Is Cornell applied that? We have that here. There was a study here in Saskatchewan that also were using the same framework. So, and then I just need to publish that. This is a poster that I did with where all the information is, how that was done, what are the means. And here, you can take a picture of this if you want to see the whole presentation that was given 2 years ago in the Soil Health in the Great Western Canadian Soil Grace Conference that we're going to have that next month. Oh my God, it's only the year. So with that code, you can go in to see the whole presentation that I have, and there's more information there. This is the curves that are, the baseline indicator that we use depending on what the indicators were working. And here is ours. The one that has the blue is the Alberta one. And the one that is the green, because I cannot copy everything, they can sue me, right? Is I put a green, so I changed the color, so it's blue. Anyway, so this is how it works. When you have blue in your report, it means very high score, 80 and to 100. What the score mean is you are comparing your soil with a base data, and that is the whatever what it is. So we are looking for and seeing what we have there and make that better in our report on our soil. Here, 300 PSI. And then that's the reason I need a texture, because I need to see each one behave completely different, depending on the texture of the soil, and that's what is there. And look at the similarity, the active carbon scoring function. The green one, this is Cornell, the one that is to your right, and the other one that is to your left is Alberta one. The whole data give that information. The same for, microbial respiration, I did a total carbon nitrogen scoring, even water infiltration. So each one of those soil indicators have a scoring function. Do you understand what a scoring function is and the importance of that? So that is what allowed me to see how the soil is. Now, everyone asked the question, what do we do next to bring soil biology back or wake them up in our soil? Do you think I have an answer for that?
Increase organic matter?
We can figure it out, right? We do soil analysis, we start working on it, but we need basic information. And that is the part that I'm bringing to you, and then I'm bringing a little more this time, and I hope you guys don't kill me because this is a lot of stuff that I'm gonna be telling you right now. Let's look at the chemistry right now. And then I know you know a lot about the chemistry, but when you have the soil pH, that gives a lot of information. Some nutrients are, being available, and then you have acid soil, alkaline soil, you have neutral soils that have different, way to respond to the system. If we have moisture, we don't have moisture, all of this. And then also that soil pH affects the biology in the soil, like you can see right here. If you have too acidic soil, some of the bacteria doesn't grow, but it's not being affected for fungi. So that is kind of general why that is important to know. But this is the more fascinating part. So in the soil, we have all of these minerals, like you can see there: manganese, copper, phosphorus, molybdenum, zinc, nitrogen, boron, magnesium, iron, potassium. We have silica. We have all kind of different nutrients there, and minerals. So guess what? You can Google the Muller chart, which allow you to understand this more, but I'm going to go with that. So what I mean is there is antagonism. If you have certain mineral in certain level, guess what's happening? Antagonism means that it's just suppressing other nutrients to be taken. So in this case, when we have high zinc, we're going to have iron being, not be uptaken for the plant. But when we have calcium issue, guess all the minerals the calcium is been affecting. So this is important for us to know when we look at the soil and the chemical part. Now, potassium also has an effect. So when you have too much potassium, it's going to be affecting your nitrogen uptake, and then if you affected your nitrogen uptake, the plant is not going to be kind of growing in the way that is supposed to, because they have the nitrogen constraint. Nitrogen. If you have too much nitrogen, you're going to have some issues with boron, and copper is affected. And then that's the part that I think is important for us to see. So there is another situation that happens when we have certain minerals in the soil. When it's too high, for example, will stimulate another minerals, and that is whatever you see there in red. And putting everything together, that is how the things look. You see? It's very complex. And then we can see that in another word, those ratios. You see? We have those ratios, and then if you have certain sulfur nitrate, it's going to be good for protein synthesis, for the microbes, and then even in the plants, and all of the things is something that we need to be looking at. The good thing is, you see this ugly instrument? Huge. I'm not going to tell the story about that, but the good thing about this is this will allow us to measure all of those minerals and more that you saw right there. That will give us freedom of doing whatever we want. Will give you freedom if you want to come to the lab and then see how things work and why is this and why is that. You've been hearing the same, that you need to know what your total minerals in the soil, right? You hear, it's important that we know what we have there. Well, we had the opportunity, I put the setup for us to measure that by having a block digestion that allowed me to cook, let's say it in that way, materials that allow me to put everything in solution and come and put it in this little machine and blah, 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 give me all of those minerals. Okay, so with that in mind, I want to introduce you guys to another part here, which is the ratios. So this is a soil that I took as example, And when I look at the soil, I just look at the chemistry. And when I look at the chemistry, I start putting all of those ratios and see how they behave. And this is what I found. So there are different ratios that has a functionality in the soil. And this is something that I put together just to see how can we change those ratios. If we don't have the ideal ratio, and this is something that has been studied in the States and different places, but I was introducing to this here in Canada through Dr. Mir Sayed. He, when I start talking to him, he's the kind of person that you ask a question and he gave you an answer that you will understand, no an answer that tells you, don't worry about that, it's working. Nobody convinced me with the answer. So when he said that to me, and I remember I asked, how can I deal with this high magnesium that we have here? He immediately said, you can use humic acid, because humic acid does this, and then it made me things more clear. After that, digging more into this guy, I learned that he was into the ratios, and then back home, when I was in Venezuela, because I come from Venezuela, I used to work in a research center there with coffee. At that time, I was working with ratios of calcium, magnesium in the soil and in the plant. I'm not gonna go there, but I fixed a problem just using the ratios. So I find someone here in Canada that has ample experience in that. Guess what I did? Squeeze his brain so much that I have maybe 60, 70% of the information through him that allow me to put together a template that allow me to do all of this. I know what the ratios is in the soil, I know what the ideal is, I know which one I can get just applying some of those minerals. And then I say application in the soil is important because you want to fix the problem in the soil. And you have to start with a little bit so you can ignite the system. And that's how things work. You will not be able to fix every single ratio, but if you are able to monitor that and changing some of this and allow that to do the changes that needed, little by little, you will be getting into the point that your production is going to be improving, your soil is going to be better, and that's it. Here are some of the ratios and what they do. I'm not going to go through those because it's too much, and then I have a lot of stuff to do, and then they are going to kick me out of here. So, but this is information that is right there available. And then I look for that, and then I put it together. So for me to understand how each one of those ratios work. And those ratios work in this way. Biological. And then if you improve the biology is going to improve the physical, and the physical is going to improve the area for the root to grow properly. And then if you fix the ratios in phosphorus involved there, you get a better rooting system, and the plants start growing better, and the roots start giving oxidation of the mineral or compounds that they produce, because they take the minerals that interaction happen with all this biology doing and decomposing and doing all in the soil, and guess what's happening? The system start getting back to itself in a natural way. But we need to help it. So you are organic, and you are not allowed to use certain minerals, but I find out there are minerals that you are able to be using. You just need to look for those sources and start playing with it. Okay. Each of these ratios influences how nutrients interact in the soil and how effectively plant can absorb them. Balancing them helps enhance biology activity, optimize nutrients use, improve plant resilience, and maximize yield potential. So all of this is what we do, just changing a little bit of this ratio. So in summary, proper nutrient ratios, you know what it's going to be start doing for your soil. And Another thing is they are able to influence the physical constraint in the soil. This is a recommendation that was done by Dr. Meir, and this is what he said. They said, the soil health lab data and issue report says, good soil organic matter, but poor nitrogen mineralization, high potassium, magnesium, compaction issues, and using the ratios allow him to kind of get it into something like this, and this is the actual recommendation. He recommended some nitrogen, some P, and then some calcium, some sulfur, copper, boron, and humic acid, because all of that playing together in there. Now, I'm going to share with you guys some of my experience in the different management that I've been putting together, starting in 2014. And this was my first experience. At that time, I only want to see some roots. 5 minutes. Shoot. 5 minutes for me, but my one that was before, he took 10 more minutes. Okay, perfect. Okay, so I'm just going to show this very quickly. I wanted to plant this cocktail mix for a few days to see how they will change the soil. This was planted in August. In October, this is the grow. Look at the soil. This, they has cocktail mixes, and the other was chem fallow. Nothing was growing in there. I just wanted to see that. And here is how they look like. This is the soil that has the chem fallow, okay? And this is the soil 2 months later. There has, this is the cocktail and chem fallow, nothing changed there. So the winter came, killed everything, the time passed, and then I came back 8 months later. This is my chem fallow. You see what you see here? Very clear platy structure. You see? Now, this is my cocktail crop. You see? Did you see the platy structure there? No. This is the soil. There's chem fallow. Look how it is. Look how compacted it is. And you can see that. This is the one that had the cocktail mix that grew only for 2 months. Look at all the aggregates that you can see there is round, and then you can continue looking at that, and that is the big difference. In 2 months, 9 months later, you can see how that was built up, that soil, in comparison with the chem fallow. Another example, Kevin was talking about my experience having, I don't know if you were in his presentation, where I was planted individual crop in a year that was so dry, and then you can see how my earth sucks, my triticale horrible, my peas didn't grow, my fava bean, I don't know, you cannot even see them, and then even the chickpeas. When I put all of that together, look how they look. The same plot. Exactly like there. And here you can see one to another. Look at the triticale and look at the other one. And this is what I find out. You know Kristen Jones? You know Gabe Brown? They were using my photos. And then I'm not even taking advantage of my stuff. This is me, right there, 2015, showing the importance of having all of these crops growing together because we had mycorrhiza, because we had Zichines, all of this. I'm going to go very quickly because they're going to want me to finish this. This is another experience that I see. This is not mine. I just walk in. So if I see something and then walk in your field, don't shoot me. Because this is what I found in this field. See all of the biological activity that is here, all of the level of, decomposition. I used to be an international consultant, which means I was unemployed when I came to this country. And I went to West Africa, where the cocoa production is, and this is how they look like. When I saw that field like this, I looked for my archive of pictures, and look at that. The different level of the composition was not different than Andy's field, which is right here in the southern Alberta with a dry condition when we don't have exactly the condition. But guess what? He put that cocktail mix in the right time, at the right moment, where all of the biology, look at the biology. You see? And this is the most interesting part. I pull it out a plant. This is one plant. One side was compacted and the other was aggregated. So I'm not going to go through this, but it's important that you can see how the aggregations are formed. And this is also from my field. Look at that. They are exactly the same aggregates right there. The ones that you have in the book, I had the pleasure of taking a picture of that. So that is what makes when you have a kind of, different biology behaving in the soil. Look at all my roots in that area that they were growing perfectly. You know what this is? Kochia. Did you see any, formation aggregates in the root? No, it's compacted. You know why? Kochia doesn't care about microbes in the soil, so they don't feed them. Okay, another example, but I'm not going to go through that. Look at this. Look at the soil right there. Look at the soil that has a mixture planted in there, cocktail mixes and all of that. Look at the roots. So that's why no matter what you do, start playing with it and start looking at this. This is pretty much repeating what I say, but I want to get very quickly into so you can see the biology in the soil. Important that we follow the soil health principle. And I having a conversation with a producer and then come out with this. The more I know, help me to understand what I don't know. So the more you know, the more allow you to understand and move forward in order to do crazy things. You are welcome to come to Cara. We're going to have a lot of fun. This that you see here, few people haven't seen this. Just watch me. This is a biological community that I took pictures of a plate where I extracted with another microbiology that shows this is how the microbes behave in a soil. They interact. We talk about that. Mycorrhiza, few of the presentation were showing how important they are. They are very important. We are measuring that in the soil. We're measuring the spores, and this is the spores that we have been analyzing. Look how beautiful they are. Look at this. This is what we have in our soil. I'm not going to go through this, but I wanted you to show my biology. Here are the different nematodes that have been found. I also have this, are predatory. They have tooth to eat the other ones. Kevin was showing this tick. This is the one that, the little tick that is right there that was killed and root-feeding nematode. This is another thing that has been found in our soil. This is a fungi that attack nematode. That nematode that you see there is called Philenchus, and is a feeding root nematode. And that guy, guess what I found? That beautiful fungi growing, killing and growing inside us. So we have that natural biological control in the soil. I want to show this picture, this video, but no way. I'm going to explain what it is. There are fungus in the soil that they form rings, and then I think they have some kind of pheromone that when you see this nematode swimming, it get attracted and then go into the ring and get. And then I had the video, but you were not lucky, so you're not going to see it. You're going to see just the picture, and this is how it looks like. You see the ring, the constraint right there? And the nematode was there in front of my face. And this is another fascinating one. This is a kind of spore that also belongs to the nematodes that belongs to fungi. They swim. I witnessed then when that was happening. This one is I think there was a fungal feeding nematode, and you can see the pictures. At the top, they have few of these little circles there. Well, look at this one. They have 1, 2, 3, right? Here they have 4. Here they have 1, 2, 3, 4, 5, 6. Here, how many they have? All of them happened in my face at the time that I was measuring that, telling me we have biology in the soil that can control all the bad or good things that we have in the soil. Treat me with dignity. That's what the soil, that's what they were telling me. Anyway, so here, other creatures, more creatures that we had. This is live. You can see some of the amoebas in the soil, and these are the different types of amoeba that we have. Blah, 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 blah. Look at this. You know what that is? A creature controlling other creature. And that is what we have in the soil. Each of your soil has a unique biology. We need to feed them. So, okay, my time is off now.